Okay, let's take a look at our first question. It says, use the graph of function f to evaluate the following statements. We're given this graph, and it says limit of x as it goes to -2 from the right side. So this little plus sign right here, it means that it's asking what it's doing from the right side. So if we were to look at the graph, and it's asking for -2, we're going to look at the graph and see what it's doing from the right side. We can see that it's going closer and closer to 0. So our answer is just going to be 0 for the first one. The next one says limit of x as it goes to -2 from the left side. So this little minus sign, it means what it's asking from what it's doing from the left side. So we're going to trace it, and we can see that it's clearly going to 0 again. Okay, the next one is actually a point. So it's asking f of -2. So we're just going to look right on the graph, and we can see that at -2, x is just going to be 0. So again, our answer is 0. But if we were to ask what it's doing, say, like if it was f of 0, we would look on the graph, and we can see that we have a point right here, and we have 2 lines right here, and they're all at 3 different numbers. So if it was asking for the point of f of 0, we would have to go at this point right here. Even though these 2 lines are going to 4 and -4, that would be the limit. So if it was asking what it's doing from the left side at 0, we would have to say 4. From the right side, it's -4. But the actual point is just going to be 0. Okay, so our next one says limit of x as it goes to -2. The limit, again, is just going to be 0. We know this because from the left and the right side, they are both 0. So our answer is going to be 0. If these numbers did not match, that means that the limit would not exist, because it has to be the same from the left and the right side in order for it to exist. Okay. The next one says evaluate the given limits if they exist. So the first thing we always want to do when we're looking at limits is see if we plug in whatever x is going to, in this case it's 1, if we plug this in, would the denominator equal 0? If the answer is no, then that would be the easiest way to solve it. Just plug in the number. If the answer is yes, if it would equal 0 if you plug in 1, then you have to find another way to solve it by like factoring or whatever you have to do. So for this one, we can just plug in 1. So let's see what happens. We have square root of 1 plus 3 minus 2 divided by 1 plus 1. So that would be the square root of 4 minus 2 divided by 2, which would be 2 minus 2 over 2, which would just cancel out, and it would be 0. So our answer for that one's 0. Okay. The next one says limit as x goes to 2 of the function x to the power of 3 minus 8 over x minus 2. So this one would not work in terms of plugging in the 2 because the denominator would be undefined. It would be 0. So what we're going to try is we would try factoring, but because it's going to the 3rd power, it would be really hard to factor. So let's try long dividing. So I'm going to have to put my work up here. So inside of here, we would have to have the numerator. So it would be x to the 3rd minus 8. And on the outside, we would have to have the denominator, which is x minus 2. So now we have to ask ourselves, x multiplied by what would equal x to the 3rd? And the answer is x squared. So we're going to put x squared right here. We're going to have to multiply this whole thing by x squared. So this would turn into x to the 3rd, and this would turn into negative 2x squared. So now what we're going to do is switch our signs so that the terms cancel out, and we're left with 2x squared minus 8. Okay, now we have to ask ourselves, x multiplied by what would equal 2x squared? And the answer would be 2x. So up here we're going to put a plus 2x, and we're going to multiply this whole thing by 2x. So this would be 2x squared, and you'd subtract 4x. So now we switch our signs. So this would be 4x minus 8. Now our last step is to think, x times what would equal 4x? And the answer is 4. So you would put a plus 4 up here, multiply this whole thing by 4. So it would be 4x minus 8. Then we switch our signs again, and we're left with 0. So no remainder, it's perfect. So right up here, we're left with our factor. So that means that our function would actually look like this. It would look like x minus 2. Then we would have x squared plus 2x plus 4 divided by x minus 2. So that would be our new function, which makes it a lot easier to see that these terms cancel out. So then we're going to have x squared plus 2x plus 4. So now it's easy, we can just plug in the 2. So it would be 2 squared plus 2 times 2 plus 4, and our answer would just be 12. So we're going to put 12 right here. Okay.